My name is Ziskind. This is Angular Web and Mobile Code Sharing. So you have a new project that you just got. Awesome. That's exciting. Your client, FaceNote.com, they want to modernize the way they collect user personal data. Now currently FaceNote, their team travels around the world, their employees, collecting user private data by hand. And they write it down on a sheet of paper, then they take it back to the office, they enter it into Excel, and then they generate reports. That's how they do it now. So they've asked for a digital transformation of the process. What they want is a web app, a mobile app for iOS, and a mobile app for Android. So, to accommodate their request, this is what we used to do. I'd call this the Stone Age way of creating applications. Sorry if I hurt anybody's feelings. First, we're going to design and develop and test and deploy and maintain a web application, and then all the management costs associated with that. Then we're going to do the same thing for iOS. Design, develop, test, deploy, maintain, manage. And then we're going to do the same thing for Android. And we're going to do all these processes separately. So we want to change this. What we want to do is do everything at once using code sharing. So that's something that we can start doing today. So who is happy when it looks like this? FaceNote.com is happy. They saved a ton of money. You're happy because FaceNote.com comes back to you for more projects. And everyone is happy because adding new features is now going to be easier and take much less time to do. So why should you care about native at all? Why not just create a responsive web application or a PWA and forget about it? So years of usage data tell us that native and web apps each have their own unique advantages. Native is known for providing really rich, performant experiences, and data tell us that people with native apps, they use them, the amount of time they spend using these apps is much higher than web apps. But the web also is known for its reach. The web isn't restricted by device type, they're not restricted by operating system, and web apps run everywhere and are a good way to reach a large number of people in diverse populations. Those slides were done by Wroblewski a couple of years ago. Here's a quote by him. The web is for audience reach, and native apps are for rich experiences. Both are strategic, both are valuable. So when it comes to mobile, it's not web versus native, it's both. So is it possible to create an app for all platforms while reusing as much code as possible and still get native performance, good native performance on mobile apps? Well, the answer is yes. So to accomplish code sharing, we're going to use NativeScript together with Angular. NativeScript provides the building blocks to cover iOS and Android, and Angular gives us the web piece and code sharing friendly architecture. So I want to ask, who here has used NativeScript? Daniel, Kirill, and somebody back there? You deserve some socks. Here you go.
Can I walk around here?
Yeah. Here you go. Okay, thanks. So when you used this NativeScript, have you used the CLI approach? Yes, he's nodding yes. Now, there's a lot of you who haven't, so I just want to briefly introduce those who haven't and tell you what NativeScript is. NativeScript is a cross-platform framework. It lets you create native apps for iOS and Android using a single code base. And you write it in JavaScript or TypeScript and CSS. So those of you that are familiar with Xamarin, NativeScript is similar to Xamarin except you use JavaScript instead of C#. NativeScript is also similar to React Native, except you don't use React. Instead, you can create apps with pure JavaScript or TypeScript, and you don't need to use any UI framework, in fact. Or you can use a UI framework, you can use Angular or Vue. We're going to be focusing on Angular in this one, guess why? So NativeScript is not like Cordova PhoneGap, because instead of using a web view and rendering a web application inside a web view, NativeScript gives you fully native UI. And it also has zero-date access to native APIs. So as soon as a native API is available, you can talk to it in JavaScript. So that's a quick intro for those that are not familiar. So besides the CLI, there's other approaches to getting started with NativeScript. Sometimes setting up a dev mobile environment is tedious. There's a lot of stuff that could be tricky. So some simpler approaches are, you can use the NativeScript Playground. It's a really fast way to get going. You can start building your applications right inside a browser and run them on a real device. And there's also NativeScript Sidekick. It lets you do cloud builds, so among many other things. If you're working on Windows or Linux, for example, and you want to build for iOS, you can build for iOS in the cloud. That's what Sidekick will let you do. So let's get back to code sharing. What does code sharing mean, and how is it good? Code sharing has its roots in the dry principles of software development. Dry, or don't repeat yourself, is something we always strive when we architect our code. We want to write our code once and have it, available in lots of different places, and not have to copy it back and forth. When FaceNote.com wants to have a web app and 2 mobile apps, we could do it the old way, where we write a web app and then carefully abstract away all the business logic, thinking it's good to keep it as a separate layer, which is a good idea, but it doesn't go quite far enough. And you also might have different, if you started the project in iOS, you might have a different technology stack that you're using for that. So to share code between web and mobile, we've been doing it a little bit of a hacky way up to now. It was usually abstracting away business logic code, which can only take us so far. Now, who here likes to copy files manually as they're developing? You sure you don't want socks?
Will I get socks?
Okay, good. Yeah, I expected that. Nobody wants to do that. Well, maybe you've written a script that does the copying for you, okay? Well, that's great, but it's still yet another script to maintain. Who wants another script to maintain? Wouldn't it be great if this was automated for you? I'm so glad you asked. There are a few ways to share code, and these are all using the CLI approach. Now, since NativeScript is an open source project and an open source framework, there are many open source code sharing solutions that have popped up for setting up code sharing in a reusable way. And here are some examples. NX Workspaces. Who's heard of this? All right. Anybody else? Yeah, we have some stock takers. Kirill knows everything. I'm sorry, who raised their hand back here? Ah, okay. There you go. Gonna look good. Cheers. NX Workspaces. This is a new thing. So this is a new approach. It enables building enterprise Angular applications using proven project structure and patterns. So it's a pretty robust approach to code sharing. And NX stands for Narwhal Extensions for Angular. We won't cover it here, but it's actively being used out in the wild for enterprise applications. Now, for those of you that are going to fly to NGConf this evening and catch the red-eye flight, maybe some of you will, or see the videos later on, you'll hear a tool called XPlat. XPlat is a tool for NX, and it's distributed via an Angular schematic to provide easy setup for code sharing. Right now it supports the web, of course, iOS and Android, and soon it will support server-side rendering and Electron. AngularNYC Advanced. This is an older project created by Nathan Walker. It's one of the original, and it's a seed. You basically clone it. It's a GitHub project, and it has many options that are quite involved. It's still being maintained, but NX is favored now at this point. So if you go out and see that one, you probably want to just switch over to NX. Angular Native Seed is by Team Maestro and Sean Perkins. It has been the simplest way to start code sharing projects up till now. And finally, upcoming CLI updates. Now this is not officially released yet, but it's coming very soon. Think about it. Wouldn't it be awesome to be able to generate code using your Angular CLI, ng, whatever commands, and be able to use Webpack to perform automated code splitting? Now, NativeScript has just been released in version 4 with some huge update improvements, and improvements in UI, but there will also be these new CLI updates, and NativeScript team is working closely with the Angular CLI team to get it ready. I'm going to show you a preview of the newest approach to code sharing that is going to be out any day now. This is not officially released yet, but there is a public GitHub repo that has it implemented, so I decided to share it with you. Let's take a quick look. You don't need to remember that URL if you can't see it. It's going to change, and yeah. I just wanted to show you the process, and that's what's important here. So I've cloned this GitHub repo to get started because it's not officially out yet, but it'll be supported very soon. So I cloned it. Then we go out to the command line. I'm going to rename the repo to my own local directory, web mobile. I'm going to switch to that directory. And let's go ahead and install all the dependencies from npm. All right. Now I'm going to open this up in Visual Studio Code, my favorite editor. And if you take a look here, you'll recognize the familiar Angular project structure. So we have the Webpack config file there that's already configured for NativeScript and Angular. There's package.json with Angular dependencies and NativeScript dependencies built in there. Fairly recent versions. And then we have our app directory, which has all our source code. So you'll see that you have familiar app component here, and the TypeScript files as well as the HTML. So what I'm going to do here is I'm going to go out to the command line, and I'm going to use good old Angular CLI, and I'm going to start a server, ngserve, for that project. It's going to go ahead and quickly build it and pop up a browser, and there's a beautiful application. It says web. It does a lot, I know, but it just gives you an idea. This is running from a shared code base. I'm going to pop open another tab and use the NativeScript CLI now to run the same code base, the same project, in an iOS simulator. It's going to take a second to pop up. And there is our iOS simulator. You can do the same thing for Android as well. And this is just a simple project where if you tap on that button right there, it's going to decrement the counter. So, let's go back here to the code. And this app.component.ts is shared between the web project and the native project. Just wanted to show you that. Here is the HTML for the web. You saw that, it's just an H1. And here is the markup for the native side. You can see that the markup is a little bit different if you're not familiar with native markup here. I'm going to go ahead and copy this native markup. I'm going to paste it into our HTML side, into the web side, so we can just reuse that. I'm going to rename these. Now this is not code reuse, I'm just showing you that it's pretty easy. I'm going to rename the stack layouts to div. I'm going to rename the label, which is a native element, to a span. And then there's our button. It can be uppercase in HTML, but I'm going to switch it to lowercase. And the button has a tap event in native, but it has a click event in web. So I'm going to change that. And there's no text property on a button, it has to be in line. And finally, the final label, I'm just going to data bind that to get message call so we can get that counter printed out and convert the label to a span as well. Now, as soon as I save this, let's go check out the website, and there it is. Sorry if it's a little small, but if you tap on that button, you're going to decrement the counter. It's running the exact same code base. One file, which is pretty cool. So, just to prove that to you, I'm going to go back here into that code, into the app component TS file, and I'm going to add some styles to it to show you that it's working. So I'm going to add a class here called myButton. It's going to have a border of a certain width, and I'm just going to add a border color of red. Then I'm going to take that class, and I'm going to paste that into the button in the native side, and I'm going to paste it into the button classes for the web side. Now let's take a look. There we go. On the web, we have a button with a red border now. Click, click, click. And on iOS, we have a button with a red border. All right. That was my demo. Thank you. Red borders, everybody. Red borders. Okay. So, I've already mentioned Angular is the primary driving force that allows us to do this kind of code sharing. How does this work? Let's get into some nitty-gritty stuff. First, Angular supports data binding and event binding, something you're all probably familiar with. It's a mechanism for hooking up parts of the template, which is your markup, to parts of the component, which is your code. It comes with binding markup that tells the app how to connect both property and event bindings. Additionally, Angular abstracts out the renderer. So the renderer makes our component templating, it makes our components and templating language platform agnostic. Angular does that. So components imperatively interact with the renderer. Angular uses the renderer to set up host listeners and host bindings. Then it uses the renderer to render the template and set up event listeners. And then it communicates with the DOM, for example, by calling doc.createElement. Some of you might be familiar with this already. The DOM returns the element, and in the end we get an application rendered to the screen that we can interact with. This is the website. Notice that cloud over there that says DOM. Let's take a look at how NativeScript does it. Now the NativeScript provides its own implementation of the renderer. Instead of communicating with the DOM, since there is no DOM in a native mobile UI, the renderer communicates instead with the mobile UI layer, and the final outcome being a native mobile app. And as a result, we have access to same components and same templates from a native mobile app. So let's take a look at some code. There's my component, and we have some properties on there. We also have an event there. Say hello to is a handler for the event. And here is the example of a web template for that component. So we have a div, we have a span that binds name and Twitter, and we have a button with a click handler that's bound to say hello to. Let's take a look at the native markup. This is where the difference comes in here. We have a stack layout, and then we have a label that's bound to name, and a label that's bound to Twitter. We also have a button with a tap event this time that's bound to say hello to. Okay, let's talk about dependency injection. Angular provides us with this mechanism, which can be used to provide web or mobile specific services, modules and services. In this case, we have our hero service that's being injected into the constructor of a component. And here's a more concrete example. The way HTTP works on mobile is much different than the way it works in a browser. As a result, in a web project, we have an HTTP client module in our ng module. We're importing that from Angular. And we're importing it into our imports array in the module that we're using it in. While in NativeScript projects, we provide the NativeScript HTTP client module. And we're getting that from the NativeScript Angular package. And there we are importing it into the module. So, when we finally get to use HTTP client, we can safely use it without having to worry about which platform we're using. We're using web or mobile, it doesn't matter. So here's, for example, my HTTP service. We're injecting HTTP client into the constructor. At this point on web, it's going to be Angular's HTTP module providing that client, and in the NativeScript world, it's going to be NativeScript HTTP client module providing the client. And finally, we can use that HTTP client to call our get statement, do fetches. All right, so that's what Angular brings to the table, which is pretty cool. Now, to get web and mobile working together in one code base, some of the other tools that I've mentioned earlier in this talk, such as the Angular native seed, use a custom build process by using npm scripts and gulp. Now, this was good for a while, and it's something you didn't have to maintain yourself, but it had its limitations. With the new upcoming CLI approach that I've showed you, the Angular CLI team has been working, and they've been helping the NativeScript CLI team to get it working with Webpack. Now, it's using Webpack and set up new loaders. Webpack is pretty much the standard way now to do front-end bundling of your code. So let's quickly go over on what can be shared. Well, from a code perspective, we can share services, pipes, directives, routing, components, and we can also do a fair amount of SAS variable sharing. We'll get back to CS in a second when I'm talking about what's different. Markup is very different. As you've seen, markup cannot be shared at all. Markup has to be specific for native platforms. Anything markup related, so for example, if you have CSS that's targeting an element like a stack layout or a label, you won't be able to share that. And anything else you want. Pretty cool, right, that last statement? Anything else you want. What do I mean by that? Well, there's certain conventions you can use in your code. If you want to code share, you would just go ahead and write your code as is. But if you want, you have the capability to be able to run different code paths by using file naming conventions. And that's for any type of files in your project. So I wanted to show you one last little demo here, and that's a continuation of where we left off, but I've done a couple of things with this project. So if we take a look at the HTML here, on the website I've added a Kendo chart, which is just a plugin to show charts. And there's our H1 that shows all items. And on the mobile side, on the native side, I have a free plugin called Red Cartesian Chart. It's also showing a chart. And there's our label that's styled like an H1 at the top. One component class. And right now I'm binding our charts to categorical source, which is just an empty array. So there's the website, there's the native side. We have an empty chart in both of them. So let's do something about that. I'm going to go and create a services folder. I'm going to create a service called My Data Service. This is just going to provide some data. Now you have to imagine in your minds that we're going to go fetch this to the web somewhere. But instead, what I'm going to do is I'm going to hard code the data right in here. I have stashed right here. I'm going to take this categorical source, which is just an array of JavaScript objects, and I'm going to paste it here in my data service. Okay, I'll make it public so we can just access it directly. So my data service is something that I can inject now into the component. So there's the constructor. I'm going to inject my data service right here into the constructor, import it, and then when I initialize the component, I'm going to set the local categorical source array to the one that the data service provides with the actual data. Cool. Of course, my data service has to be provided, otherwise Angular will yell at us. So there's our app module. We're going to just add it to the provider's array here in the module. And there's our specific app module for NativeScript. So here's an example of where we're using different file naming conventions. Okay, we get a chart. It's kind of hard to see with the color, but I hope you can see that. And there's our native app restarts, and we get a chart there. Cool. All right, so I just wanted to quickly perform an experiment on this project that I did, very simple project, and I wanted to count the number of lines and convert it to a percentage, the number of lines that can be shared. So total app code lines, 228. Now this is just application code. And total lines that are platform specific is 29 lines, which comes up to 87.3% of code reuse. Now my simple project, of course, is not typical. Typically, there's about 60 to 80% code reuse in real world apps. So that's huge. Summing up. So we know code sharing is good for us, and especially for FaceNode.com, so they can collect personal data even more efficiently. But why is the newest CLI approach so good? It's built on standards. It's built into the existing CLI workflows that people are used to. And you don't have to maintain it separately. So all those are good reasons. And finally, I want to say thanks to all those who could make it out tonight. And thanks to all the other speakers. And thanks for everybody for not heading out to NGConf and coming to see us instead. Token of thanks, I just wanted to give you all a coupon here for NativeScript courses or bundles on nativescripting.com. So if you want to go and check out some courses, there's some free ones on there as well, and there's some premium ones, and you get a 25% discount if you use this code. Thanks a lot. Questions, please? Yes?
So the two different models that you had, one was the NativeScript specific versus the Angular generic one. Is that how you would accomplish the HTTP replacement that you demoed? Where you would provide the NativeScript one in the TNS and you provide the Angular common one in the non-TNS module?
So if you're using the HTTP module, as in the example that I showed, you don't even have to do anything. All you have to do is import. I think I know what you're asking me. You're asking me, where do you import these, right? Okay, so I'm going to assume that. So there's two different modules here. One module is for the web side, and one module is for the NativeScript side. In the web side, you're importing all your web-related modules and components. So these are all your dependencies that are web-related. See Hammer.js in there, there's no way that that's going to work on a mobile device. On the NativeScript side, and as you can see, my file here is named .tns.ts. That's being handled by the build process, by Webpack, and that file is being used instead of this file when you're building for native. And here, in this file, only the native declarations and dependencies are used. So all these dependencies in the ng module are native side.
I know this is a little out of context, but can I use the same build process for hybrid apps?
So natives can use the same build process for hybrid apps. Are you talking about, for example, Cordova or Ionic? Not this build process, but I'm sure they have their own build process that's going to be able to do something for you. This build process is specifically for NativeScript apps. It's going to create native apps for you in the end, not hybrid apps.